Quick test. Can you hear me? People of the Twitch. Folks of the network. You can hear hallelujah. So I am very happy to return to Jai Wednesday. It's definitely been fun the last couple times. Um, now, last time the stream was over an hour. It was like an hour and 20 minutes. We should try and keep it under an hour this time. Again, for the benefit of those who will watch this stream later and things like that. And what I really want to tell you real quick before we get started, I think you can see it on the presentation. We have a Twitch FAQ available. So the frequently asked questions are on the Twitch page below. So, check it out. Some cool stuff there. Now, let's move on to one of the topics that would interest us, which is workspaces. Although I believe there was one question that was left unanswered last time. Hold on, let me shut down my phone. Yes, Merry Krampusnacht. That's for sure. There was one question somebody had about iteration. So let's just quickly answer that, right? I didn't fix my indentation. We can keep it as a running gag at this point. Okay, here we go. Here we go. So imagine you have a for loop that iterates from 0 to 5. And then for each one of those items, you want to iterate 3 times, right? And you want to print, let's add some I, for I, for J, classic. And then print I is this and J is that. Gotta love that you just use %, and that's it. No need to remember any of those weird format specifiers. Okay, so the way this will look is basically, well, let's just run it. Okay, again, compilation is a little slow because we have a lot of debug stuff going on. And I'm running, I'm running on debug mode right now. I wonder if I can quickly fix that for you guys. Well, let's just run the program first. So iteration. Okay. So, I is from 0 to 5, right? And for each element of 0, 1, 2, 3, 4, 5, you're going to get 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, right? Now, the question that they were asking me last time was, okay, what if we get rid of I up here, right? What if that happens? Well, usually you get access to these elements, to these numbers with it, right? If you don't give a variable, an identifier here, it's just it, right? And you can maybe access it here, print it. And that will work. But the question was, okay, what if I'm inside this nested for loop? Can I still access the it from the outer loop? That's what the question is. The answer is yes, right? So I could remove this I and say it for iterator. It stands for iterator. And compile again. Da, 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 da. And there you go. It's the same values as last time. So I goes from 0, 1, 2, 3, 4, and 5. Okay? Now the question is, hey, what if you get rid of the J as well? Right? Then what happens then? The answer will be apparent once we compile. Oops, we gotta get rid of J, right? So let's just say it twice so you guys can see what's going on. Boom. 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. In other words, the it is only now referencing this loop's it. And now you lost access to the outer loop's it. Okay? So in other words, you can't get to this anymore. That's the answer. Question from the chat. If you're printing a float, how do you specify how many digits after the decimal point to print? Well, the system modules of the language provide you format structs, right? So you can define a struct that talks about a format of the float. You specify the base and you specify the precision, and then you pass that in, and you can get the print results that you want. I don't want to go into that today, but we can do it some other stream, right? Alrighty. Let's move that over to the basics. Okay, and we're gonna start a new folder. We're gonna call it Workspaces. All right, we get to talk about Workspaces. That's exciting. Here we go. Is there a struct that can represent ranges? I haven't used one. Maybe somebody on the team added it. I'll have to double check. I don't think last time I wanted ranges, I don't think it was there. But who knows? Again, there's 4 people working on the compiler, so I don't catch up to all the system modules all the time. But I should probably check that out. Okay, so Workspaces. Yeah, before we start streaming projects again, like the Blobman project, we want to talk about Workspaces because it's one of those features that is fairly unique about the language, and it's very interesting in its own right, and it's very useful as well, right? So it's one of the defining features of the language. So let's open up, first of all, a file, and we're going to call it list.jai, right? I'm going to explain what this does. Let's just set the font to 14. Okay, we'll import print as always, and we'll have a main as always. Poor man's version of ls, right? Those who don't know what ls is, if I do ls right here, it lists how many files and directories are in the folder that you're in the working directory, right? Now, let's take a look at how we can write that. Well, we can maybe pass an argument, right? So we can say, give me the compiler arguments, the user arguments from the command line. I think it's called like this. We don't have module namespacing just yet, although it's coming soon. All right. Get command line arguments. And then let's just print those. I assume people here are now finally are accustomed to the syntax. If you're not accustomed to the syntax, it's on the frequently asked questions. I have some notes for you to follow if you can't follow the code, right? Okay. Let's say I want a list, which is going to be a string array, and I'm going to call another system module that I need, file utilities. So file list, and the path will be equal to the argument. And I don't think I want it to be recursive, right? Now what I'm doing is, hey, for every command line argument, I'm gonna assume it's a path, a folder, right, or a file name, and we're gonna get the list of the files inside that path, and now we're going to print them, right? First of all, I'm going to check if the count is 0, because then it means there are no files in that folder. And then for every file on the list, we print the file, right? Well, let's see if that works. Well, let me first switch to the fast version of the compiler, the non-debug version. And even then we do instrumentation, right? So it's not at its fastest. Maybe we can change that next time. Just make it as fast as possible. Let's see. Oh, if you don't, by the way, I'm over here changing the path to Jai, to the compiler. So it can be release mode instead of debug mode. There we go. That means we also need to exit. So let's just close everything. And let's reopen the console. Give me a sec. I have this Linux server that's always running automatically. I have to cancel that. Yep, we'll do this. Start. This is live, folks. Live. CD into streams. Okay, back to normal. Oops. Stream. There we go. Workspaces. Okay. See, still slow, but we got it. List.exe, right? So let's make a folder. We're gonna call it test, and we're gonna put in. Let's see. Let's go into test. We're gonna make a few fake files. Okay. Let's see. Ralph the Mighty .text. We're gonna touch recursive chat.text. We're gonna touch sasluka.jai. Then we're gonna touch organumkin. I like that one. .wtf. Right? Hooray! We got the files! And now that we have the files, we want to list them with our program. We want our Jai program to list the files that we just touched, right? So here we go, Jai. Oh, sorry. What's it called? List.exe. And then we'll say test. And that's the one I care about. Boom, right? That's simple enough. Simple enough. So let's go back to list. So we have a poor man's version of LS, right? Not a lot of code either. This is still statically compiled native machine code, and it wasn't a lot of code. So excellent. Now, before we get to workspaces, which is what you guys want to know today, there's something to explain before that, and that is the notion that Jai code can shift, right? This same code that you're seeing right now, that it can shift from from runtime to compile time. In other words, what you can run, when you run this code at runtime, you can run it at compile time if you want to, right? So you're just shifting the timeline to run this code when the compiler is compiling, right? So when the compiler is compiling, you can choose to run this code already there, right? And then you can choose to compile and run it later at runtime, or you can run it at compile time while the compiler is compiling, and then you can tell the compiler, hey, I don't care about runtime anymore, so don't produce list.exe, right? Like who cares, right? How do you do that? Well, there are many ways you can selectively choose blocks of code to run while the compiler is compiling, but the most popular one, at least in the team, is this compiler directive called run, #run, right? So with #run, now this code will immediately run at compile time. Of course, this is sort of, there are ways to do this, right? So you could probably do it like this. There are multiple ways to use run, but this is the classic one. Okay? So let's do it that way. So jai list.jai we are going to get an error potentially because there are certain things that you can only get at runtime, right? And that's not a problem. It's just how it is. Because get command line arguments only works if you're asking them from an executable. That's just how the function is defined, right? So I think an easier way to handle this, I would say, is to do it this way, right? Which is even better because it's less code. So run, and then open block, and then whatever's in here, right? And now, again, I need to stress, get command line arguments is defined to take command line arguments from an executable. So this is not going to work as it is. But we have something called this version. And now you're good to go, right? So I'm calling jai list.jai. This is to compile the program, right? But now the compiler is going to find out that there's this run directive and it'll run it, right? Now, this compiler get command line arguments is going to expect arguments at compile time. And to specify arguments at compile time, you do a dash dash, right? And then you specify all the arguments you want in any order, right? So I, LOL, the Berk is real, etc. You know? But let's just let's actually pass the test folder, right? And let's take a look at that. Whoops, that's my bad. We need a semicolon here. Syntax is not final in the language, so don't, things may or may not change with regards to, I'm not even gonna say anything. There we go. So you have the files right here, and you didn't have to compile an executable to get it, right? Now the compiler says, hey, where's main? Where the heck is main? Well, we just didn't provide it. Now let's say that you don't want the compiler to complain that it couldn't find an executable, because that's the compiler's default behavior, is to compile, run things that you tell it to run, and then find main and output some executable. But we can, or library, right? Something else. But we can tell it not to do that, right? And I explained this on the first stream, but let's just do it quickly. Here we go. List.jai will not produce any executable. Build options, get build options. Again, if you don't know what I'm doing, you can go to the first stream where I do talk about this. Build output type, no output, set build options to the build options. And now it's not going to complain anymore. Real quick, what we're doing is telling, hey, compiler, give me the different ways in which you compile my program. Now I'm going to update those build options to say I don't want any output. And now I'm going to give it back to you. Hey, I modified the way in which you compile my program to say I don't want an output. And there you go. And it'll follow those instructions, right? Let's try it again. List.jai, the test folder. Excellent. Excellent. And we have our thing working, right? Now the changes were minimal, right? Like this, you didn't have to do this. You just, trying to make the compiler happy, but you didn't have to do that. And the only change that we had to make, besides getting rid of main, which we could have kept, is this little function, right? Because in this particular case, we do care about the distinction between compile time and runtime. But if this function didn't exist, right, and there was some other stuff happening here, then you didn't have to change anything, right? You could have just kept main here, and you could have said run main, right? And that would have worked. So all you had to do was add one line of code, right? I just chose one example where you need to care about the distinction, but that doesn't happen very often necessarily, in my experience. All right. Anybody got that? Any questions before we finally touch the workspaces? People are talking about pound. I say hashtag. I'm from Puerto Rico. I learned English as a second language. I like hashtag, and I'm happy. All right. So let's go with workspaces, right? This is gonna be interesting. So now we know that you can choose the timeline in which your code runs, whether it's at runtime with an executable or while the compiler is compiling, right? And you can even tell the compiler to stop compiling after it ran your code, right? So it's a blurry line now where the compiler is being blurred between those two things, which is very, very useful. Now, where does a workspace come in place, right? Well, let us, no, I didn't have to present. Come on. Let us make a new file, right? Workspaces.txt, because I'm gonna explain something, right? Always fun to take some time doing this. All right. So the way the compiler typically works is this is a conceptual sketch, right? But you feed it a file, right? You give it a file. So user program.jai, right? And that is gonna go through some stages, right? So what first is gonna happen is that jai fires off. Let me say it differently. The compiler creates a workspace. So that's what's going to happen. Now, it creates a workspace because conceptually, the compiler itself doesn't do any work, right? What it actually does is tell the workspace to do work, right? That's a good way to look at it, and I'll explain in a bit why. But so it creates a space of work, and what that means is the workspace will have available all of the subsystem of the compiler to do what Jai tells it to do. In other words, let me write it down. The compiler creates a workspace. Let's rewind, right? Compiler creates a workspace, and the workspace has all subsystems available. Okay, now what are the subsystems? The subsystems are, one is the lexer, right? The parser. You have the type table packer. You have the bytecode generator. You know, when you do that hashtag run, right? Hashtag run. Well, that's going to run in bytecode, right? And so we need to generate that bytecode. So that's a subsystem that the compiler has. We have the bytecode runner. So that's when you actually have bytecode running. So earlier, the list program, the ls program, when we ran it at compile time, it was running bytecode, right? And then you have the backend, right? Which is to generate libraries, executables, and all of that stuff, right? So now, again, you give user program to the compiler. The compiler creates a workspace, and that's literally firing off a thread, by the way. So you can have compiler creates a thread, and that's going to be the workspace doing its work. And it's going to have all of this available for it, right? And what it's going to do is it's going to go step by step to compile your program, right? So Lexer, it parses, it does type inference, generates the bytecode, runs bytecode, if any, makes the backend, right? So that's cool. Now, here's the question though. When the workspace is parsing code, what if that user code decides to create a workspace itself? The answer is that it can, right? So user code can fire off a workspace thread within the first workspace, right? But what's key to understand here is that even if you don't deal with workspaces yourself, the compiler is going to create a workspace, and within that workspace, it'll call upon these subsystems to create your program. But if you want to, while the code is getting compiled, you can ask it to fire off another workspace and run code over there, right? And now, when the user asks for a workspace, it now has this stuff available to it. It has the Lexer, it has the parser, etc. Right? Now, there's going to be limitations to some of the things that you can access, but a lot of it is available for you. So you can make workspaces to decide to, run a game. You can decide to send an email, right, at compile time. Or you can decide to compile a library, or you can decide to compile an executable. Why? Because you have the necessary components to do all of that. It's at your disposal, right? Now, it's best to show an example before you get more confused. I think I explained that okay-ish. It's a new concept, right? Most people aren't used to that way of thinking, but it's pretty awesome the moment that you finally get it. So, all right, let's get rid of list, goodbye list. And now we're gonna compile hello sailor.jai because that is a classic program. Da-da-da-da. And we're gonna say, print hello sailor. So here's hello sailor. And now we are going to create our first .jai, which people already sort of know. So we have hello sailor, okay? It's available for us. And now, if you remember the first stream, I'm going to create a first.jai file to compile the program from this file, right? So now I'll explain what we're going to do in just a second. No output, and set build options to build options. And we're going to get a workspace. Okay, this is enough to sort of summarize what I just said, right? So if we give to the compiler first.jai, if we give the compiler this file, it's going to find the run directive, right? But even before it finds it, the compiler is going to create a workspace, which is always the first workspace, right? because that's the place where it's going to have the parser available and the lexer and whatever else, right? So the compiler creates the workspace thread, and now it starts parsing this file, and it finds run build, right? So it says, oh, okay, I see run build. I guess I'll stop whatever else I was doing. And then I'm going to run this code. Now this user code, remember, all it does is say, hey, I don't want an executable anymore. I don't want it from this workspace. And then I tell the compiler, now you know what? Create a separate workspace thread for me, right? And the compiler is going to do it. It fires off the thread, and now that other second workspace is going to have the parser available and all of that stuff. And it's going to try to find a file to parse, which doesn't exist at the moment, right? And do everything else by default, right? Create an executable by default and all that stuff. But you can change that. Anyway, so let's continue. If there is no workspace, then failed, and we exit. Cool. Okay, so what can we do with this concept to make it more concrete for you guys? So how about we make a project in which we make somebody compile Hello Sailor only after they've played Invaders, right? So this is a classic example that John has showed. But there's a bit of a difference, right? Because what we're saying is the project, when you start to compile it, it'll create a workspace in which you play Invaders, right? And then once you're done playing Invaders, you get that result back. If the user won or got a point or something, then we'll print a message saying, hey, you beat Invaders, good job. Now you can compile Hello Sailor, and we can do that in a separate workspace, in a third one, right? And then we're done. So again, to repeat, we want somebody to compile this file. Then we're going to create a workspace, which is the second workspace, because the first workspace is already this file. A second workspace to play Invaders, right? Then we finish, and then we make another workspace to actually compile Hello Sailor.jai, right? This is one of the many ways in which you can play with this, right? So let's do that. Run Invaders. So we say add build file. Remember from the first stream. Well, to the workspace. Okay. And then run the workspace and wait for it to complete. I guess I have to find whether Invaders is running or not these days. We'll take a look. Long Boolean. So would it be fair to say that workspaces are something like a mix between makefiles and translation units? You could look at it that way. I mean, it can be more. So again, a workspace is just the place in which the compiler has access to everything. The parser, the lexer, the backend, right? The bytecode generator, the bytecode runner, everything, all parts of the compiler are available in that workspace. And even if you don't control a workspace yourself as a user, if you just compile Jai normally, like a program regularly, the compiler will still, behind the scenes, make one workspace, right? And process your file, and it'll go through each subsystem, parser, bytecode, backend, and it'll give you the executable. Now, the difference is that the compiler, right, is exposing this internal concept to you as a user, which means that you can create your own workspace and you can access the parser, right? But then you can stop after the parser. You don't have to continue. right? But you can then invoke the bytecode runner. You can invoke the backend, right? So it's a lot of power. You can rerun things, right? Because you can then tell the parser, hey, I have this new code for you that I'm generating at compile time through a metaprogramming way. So rerun the parser phase, okay? Like you're controlling all of those things yourself. So with that much power, yes, you can turn that. You can use the workspaces to create makefile systems or to create translation units, right? Or you can make 10 workspaces in which each one never produces an executable, and all it does is run video games at compile time, one after the other, once you're done with each one sequentially, right? You can send 10 different emails in each one because, again, you have access to the run directive, which means you can run stuff at compile time in each workspace, right? So all you need to know is that the first file that you compile that you give to Jai is already a workspace, right? It's already being compiled inside a workspace behind the scenes. And you can ask it while you're in there to create workspaces for you, and you can control that workspace manually, right? So what do you say? It's amazing, and it's a different way of thinking about how to be a programmer, right? Because usually compilation happens in a way that you give it one file and it'll linearly go through each compilation phase that you have no control over, right? Maybe a little bit of control through const expert and C++ or whatever, and then you get one executable, and that's all you get. But here, you have so much power and flexibility that it's almost like your brain is like, what? Rojaster, why first.jai? Doesn't have to be first.jai. It's just first.jai because John uses it to say, hey, this is the first file I'm going to compile. It's the entry point. We can call it setup.jai. You can call it, I don't know, whatever.jai. Marco's done. Can you pre-compute heavy things while compiling and freeze them in the executable so it does not compute them each time at runtime? Yeah, absolutely. I have that as a to-do actually for Blobman. So if you remember the first stream, this is the reason I'm teaching all of this, so we can go back to my game, right? This is the game that I want beta testers to try out. So you remember Blobman, right? I have a to-do list. Let me see. Where is it? I did this on the first stream. Generate all arrays at compile time, never at runtime. Save users time, right? So I have a bunch of arrays in this game that get generated by reading a file, like a level file, whatever, creating the array, and then we use that to determine the level layout, or it can determine how the OpenGL memory accesses different indices and all of that. Now imagine that if I publish the game and everybody runs Blotman, an average of 10,000 times across all users, 10,000 times a file is going to get loaded, it's going to get parsed, and it's going to get transformed into an array for then to use in the game. But why should they pay that cost if I have the compiler giving me the option to do something different, right? I can just tell the compiler, hey, at compile time, right, generate all of these arrays because I can run any code at compile time. The same code that I would run at runtime, I can run it at compile time. Generate all of these arrays while I'm compiling. Generate them, open up the file, parse the file, create the array. Okay, now you can continue creating the executable, right? So the answer is yes, absolutely. If you don't want to, all this stuff is optional. You can treat Jai as a regular compiler. I mean, you get the benefit that it's really fast, right? But if this is too much for you, I'm not saying it's for you specifically. I'm just saying in general. If it's too much for you, you can ignore it. Can you compute constants with run 2, or do constants have to be run no array compile time? Huh. You can compute a constant at compile time, yeah. The reason I was thinking about that is more like, do you want to use a constant at compile time or at runtime, right? Would it make sense to do it at compile time? Just have the constants at compile time, but you can generate constants to be used at runtime. Yes. Okay. Anyway, let's try and run invaders, right? So let's see if I have it. Maybe it's invaders.exe. Yeah. Okay. This code was a little dead early on, but because the language syntax was changing a lot, right? But I ported it to the new syntax. Oops, I died. And now it's using OpenGL3 instead of fixed function pipeline. Okay, so let's copy invaders. Hold on. Let's copy invaders over to our string folder. Excellent. Back to stream. There it is. There's invaders. Okay. What about network files concurrency? Yes, you can do networking at compile time. So while the compiler is compiling, you can choose to do some networking. In fact, you could say, hey, I want my team to send me an email every time they compile the project completely, right, from scratch. You can write a meta program for that, right? Just use the run directive here, right? So just run send email, and then you have to define the function here, send email, and just write your code just like you would write regular code as always. All right, so back to invaders. You guys are gonna love this. Okay, so let's recap. We have this file. We're gonna give it to the compiler. The compiler is gonna create a workspace behind the scenes to compile it. But we tell it, no, don't compile anything. Instead, make another workspace for me, right? And I'm gonna control that, right? I'm gonna use the parser myself and the backend myself and all of that, right? Okay, fine. So we create that workspace that we're gonna control, and we're gonna use it to run invaders. So we give that extra workspace, that new workspace, we give it our invaders program, right? And now we're going to tell the compiler, okay, go ahead and start running or start compiling invaders. The way you do that is with this function called compiler begin intercept. And then we pass in the workspace, right? So this line right here is going to start intercepting the other workspace just to see what's going on over there, right? So the other workspace is going to start compiling invaders now, but we want to have messages from that process, like, hey, how's it going? Like, did you finish parsing all of the code, and do you have like type inference complete? Stuff like that. Are you in the phase of building the bytecode? Are you in the phase of creating the actual machine code? You can get messages about that, right? And it's from a queue, so you're pulling from a queue right now. So while true, we want to get a message. Compiler wait for message, right? If there's no message, because sometimes there's not a message, continue. If the message was, let's see. So for invaders, all we want to do is run the game and wait for the person to close it. That's all we want to do, right? Which could be, remember, I can run the game at compile time, which is what I want to do, right? Anyway, so all we want to do from here is tell, hey, once that other invaders project is done, let me know. And we do it this way, complete. We do a check if it was complete. So break, done compiling, right? And so once we break out of the loop, we can say, okay, we're done intercepting. And there you go. Right? Any questions? Now we're going to talk about invaders, like what's going on over there in that other workspace. Can you show us more about the context struct? Not in this stream. I'm not sure if I understand this question. Somebody's asking, what about a module that the compiler doesn't natively have loaded in its process? Does it realize that, or are the available options strictly limited? You can, during this, I'm not sure if I understand the question, but during this intercept, so while you're asking about messages, you're going to get messages about a file or a library or a module being opened up for parsing. You can get to that level of granularity, and you can do things from there, right? I'm only showing the basics, but you can go intense with that, right? Does each workspace have its own imports, includes, and links? Yeah, I mean, once you create a workspace, right? What it's going to do in that new thread, remember, an actual thread, the concept of a thread, remember, thread of a workspace, and it's going to start looking for a file to compile, which I'm giving it right here in add build file, right? And that will be as if you're compiling from the very first time something, right? So you're going to get imports over there and all of that stuff. Yes. Is there an example of how to compile time inject code back out to be compiled? Oh, that's interesting. Yeah, that could be a good test. Insobot exploration. All right. Okay. So this looks good. Now we want to modify invaders, right? Here we go. We want to modify invaders to say, compiler, don't create executable code while you're compiling this file. I want you to run the game at compile time, but I don't want you creating an executable, right? So let's add a run directive, and we're gonna open up the block, right? Da, 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 da. We're gonna update the working directory because we need to make sure that it can access the assets properly. And get build options. Then we're gonna say build options output type. You guys already know the drill. No output whatsoever. Set the build options to, and you can choose, instead of no output, you can choose like a library or something, right? So the idea would be you can say like DLL here, but you don't want a game to be a DLL, right? That would be, you can't do that. Anyway, set build options, and then invaders gives you an int, right? So after the game runs, we want to find out whether or not they got a score or not, right? So, okay. We can say, success is invaders is greater than 0, right? Because invaders is the game. It's the function or the procedure where the game happens. When it finishes, it'll give you a number, which is the high score. So I'm just saying, hey, is that high score, run the game, is the return value of the game greater than 0, right? You can even simplify it. You can say if invaders greater than 0, then print success. You rock. Otherwise, print, oh my God, how could you? Right? There we go. I think that's all we need to do. So let's go back to first.jai here. And now, after the player has played invaders, we're gonna let him or her compile hello sailor.jai, right? Because you haven't forgotten about hello sailor.jai, right? We have it right there. Okay. So what we do is we're gonna make another workspace. This is crazy town. Crazy town. Workspace equals compiler create workspace. We're gonna update the working directory because that applies for the entire process. It's lifetime, right? Then let's see. Same thing. If we can't find the workspace, we're in trouble. Maybe you ran out of memory on the system, right? Now we want to update the build options to say we want an executable, right? Executable. Because we're going to compile hello sailor, and for hello sailor, we do want an executable. And we're going to use LLVM as the backend. But yeah, the compiler is available for you to just be a regular programmer and compile as always, or you can be can do even more interesting things, right? And use the compiler as a build system, or send emails, or do some networking before you compile the code. You can resubmit your code, edit it through metaprogramming, all in the same syntax, all in the same place, all with the same tool, right? So you can stick with the simple stuff, or you can gradually increase how much you want to do with the compiler. But everything's available for you, and it's still very fast, right? So build options dot. I think we'll leave it at that. Set build options, workspace, and then we're gonna give it the file hello sailor. All right. So if I didn't make any mistakes, right, we're gonna give the compiler first.jai. It'll create a workspace. We're gonna tell it not to create an executable in this workspace. We're gonna tell it, hey, make a new workspace and compile invaders there, right? But our invaders code says, I don't want an executable either, right? So over there in that other workspace, it doesn't ask for an executable, but it does run the game at compile time. And then once the game is done, it'll see whether the user 1 or not, if you got a high score, something greater than 0, and print a message, hey, you won, hey, you suck, right? Then that workspace ends, and since we were tracking those messages way back here in first.jai, right, we found out that it completed. It was like, oh, okay, that we played invaders, now let's actually make another workspace, the third one in this program, in this project, and we're gonna compile hello sailor.jai and actually make an executable. Bada bing, bada boom. So here we go. Uh-oh. Unable to open file. Is that because I'm not inside Workspaces? Okay. Let's try again. Okay. Undeclared identifier build output. I think that's because I made a mistake. I think it's build output type, right? Yeah, build output type. And let me make sure that invaders, oops. Okay, Jai can't save you from syntax problems, syntax mistakes, typos. Here we go. And make sure that it's also the right thing here. Where's run? Build output type. Okay, I think it should work now. Okay, compiler message kind isn't recognized. Did I make another mistake there? Oh yeah, I did. So it's compiler message dot kind, right? Because we're accessing okay, namespaced enum. Okay. Okay. Unable to open invaders. That's because invaders is not where it's supposed to be. Move invaders over to workspaces. Now we try again. Okay. And then we want to make sure that invaders has the run directive formed properly. Let's try again. Okay, so now I'm playing the game at compile time, right? I'm gonna lose so I can get so I can hurry up. Let's see. Oops, there's a collision bug over there. Oh my God, how could you? That's because I didn't get a single point. The second workspace completes, right? And now I'm compiling hello sailor, and the third workspace completes. And we can look at it. I think it's stored in, it could be stored in, yeah, in invaders. And that has to do with the working directory. Hello sailor. And there it is. And we can play the game again, right? And actually hit somebody. So let's see. There's a collision detection bug. That's my fault because I was, there we go. I defeated somebody, right? Now let's actually lose the game so we can get a different message, right? How do I lose the game? That is that is terrible collision detection bug. I have to check what's going on. It wasn't that bad. Okay, success. You rock, right? And yeah, got the same thing done. That's it. Any questions? Gotta stop the stream. And then we could have done other stuff. We could have literally sent an email telling somebody, hey, your programmer on the team isn't a very good player of invaders. And you're like, oh! Oh! And then after that, then the programmer can compile hello sailor. right? You can totally do that, 100%, right? So I apologize for the collision bugs over there. Like I said, I'm not a game programmer, so when I updated OpenGL 2 to OpenGL 3 and wrote my own shaders, I'm pretty sure I got something wrong with um, what do you call that? Matrix mathematics, right? So now you're ready for Blobman. So next time we meet here, probably next Wednesday again, we can actually start working on the projects that we want people to use for the beta test, right? So any news on the Giant website, can you show it to us? I haven't asked, right? So I'm not sure if I can. Okay. I can ask John. I just haven't done it. Simuratori. Hey, Casey. I also thought the website was supposed to be up. It's done. It definitely is done. But I'm waiting for the team and John to review it before putting it out there. Peer pressure. I won't be peer pressured. I love you guys, but I won't be peer pressured. But I will meet you halfway. So I will talk to John and I'll ask him if I can at least preview maybe the YouTube annotations, right? Because I have a page on the website that has all the demos with all the annotations. Casey, the design has been updated. So it's no longer what you saw last time, right? We actually have a coloring theme going on there. So we give you chalk on one if you show us the website. Nah. I thought the design was. I appreciate it. Yeah. Well, now it's a lot better. Alan and our friend Nico reviewed it, and they were very critical, which was good because I made it better. So, does it have a repo? No, it's a statically generated website, and it looks nice. But I'm serving static content, documentation, YouTube videos that are embedded with some nice animations when you click on a timestamp to scrub to the relevant part of the demo, a news feed, RSS, all that stuff. I don't want to do a website ever again. We'll see if the company makes me. So, okay. I hope you like Workspaces. I love compile time execution. I love to be able to literally have this concept where with the same syntax of the language, you can choose where to shift. I already said this at the beginning, but I gotta repeat it. You saw that we can choose to run code whether it's at compile time or at runtime, and we can actually say, hey, this code that you processed at compile time, store it statically in memory for at runtime. Oh. Oh, see you guys next Wednesday.